All right, yesterday we recapped the sine rule. Let's recap the cosine rule. So again, here's our standard triangle. To create the cosine rule, again, I'm going to drop in my horizontal, but this time I'm going to put things in terms of cosine ratio and Pythagoras' theorem, because cosine rule actually really is an extension of Pythagoras. So h squared, using Pythagoras, I could say would be the same as b squared minus x squared. I'll just label x there, that little distance down the bottom. And c squared, so going to the other right angled triangle, I could say is equal to h squared plus a minus x squared. So if I eliminate the h squareds, I end up with, eventually, c squared is b squared plus a squared. There's the Pythagoras' theorem. But we have this additional bit, because it's not a right angled triangle, of minus 2ax, where x is just this piece of the base. But of course, that's very clumsy, just having x, where x is just that piece of the base. And that's where the cosine comes into it. We can rewrite x as x over b is the cosine of c, and rearrange that. We get x is b cos c, sub that in, and we get a much neater formula. So c squared is, I put it as b squared plus a squared. Normally I think of it as a squared plus b squared, but it doesn't matter, of course. Minus 2ab, the cosine of c. I guess the only thing we really need to remember to make the formula sense, whichever side we're finding, that's the angle that we're using the cosine with. And then everything else drops into place. Like yesterday, I could have put that perpendicular anywhere. I just chose to drop it from A, but I could have put it elsewhere. So it could also have been a squared is b squared plus c squared minus 2bc cos a, or b squared is equal to a squared plus c squared minus 2ac cos b, or of course the one we just proved. So that is our cosine rule. As I say, an extension on Pythagoras' theorem. All right, let's just do a standard sort of question. And you'll see the cosine rule, when we look at it here, where it's useful is where you have two sides and an included angle, and you want to find the third side. So t squared for this one will be f squared plus m squared minus 2fm cos t. So subbing in the appropriate values, once again, it's just calculator work. I guess the one thing to watch out for here is remembering it's t squared we're finding. So we do also then have to hit the square roots to get the answer. And to the nearest whole number, because again, I'm just going to match the question, 8 units. 8 units. Now, if we want to find an angle using the cosine rule, so that's a situation where we know all three sides of the triangle, then we can use the cosine rule. Some people like to remember a different formula. Others just remember the one cosine rule and then just rearrange it. Up to you, I guess, how you want to approach it. So if I did do it the rearranging way, I'd start off with the cosine rule, where f is the angle I want to find. So I'll make f squared the subject. So f squared is a squared plus s squared minus 2as cos f. Rearranging that, we get what some people like to memorize as the formula if we're finding an angle. A squared plus s squared minus f squared on 2as. If you are memorizing it that way, I guess the way of remembering it is you minus the side opposite the angle you're trying to find, and then the rest hopefully drops into place. Subbing in our numbers. Now, before I go any further, acute or obtuse? Hands for acute. Hands for obtuse. Hands for I don't want to embarrass myself. Okay. Yeah, it's got to be obtuse. All we got to do is look at the sign on the top. If it's negative, then I know it's in the second quadrant. So it's got to be an obtuse angle. And I'm pretty sure 6 squared plus 15 squared minus 20 squared should be a negative number, I think. Yeah, so we end up with an obtuse angle. We don't have the same issue that we did with the sine rule. The calculator will find obtuse angles for us when we're using the cosine rule. Now, here's one where it might not be immediately obvious that you can use the cosine rule. Because normally we say, hang on, it's when we have two sides and an included angle. But you'll notice I have two sides but not the included angle. I can still use the cosine rule. Okay. So, if I write it as a squared is b squared plus c squared, because a is the angle that I know. So I work with the angle I know, tough. Substituting what we know, and remember all it is b is what we're trying to find. And so I now have a quadratic equation in terms of b. So it is possible to find b. Let's rewrite it so it looks like a quadratic. So it's b squared minus, well, the coefficient of b is minus 14 cos 25, whatever that happens to be, plus 40. So obviously that's not going to factorise. So I'll go straight to my quadratic formula. Going to give me two possibilities for b here. Without more information, I can't really tell which one it's going to be. Because 5.85 and 6.85, both of them are in between 3 and 7. So even if I found the other angles, I can't use the idea of the largest side opposite the largest angle and so on. So best I can do is there's two possibilities for that one. Okay, 4i's, someone wearing spectacles, and 4j is then a mixture of